Hey calculus students, this video is going to be the first couple examples for topic 6.2. So in topic 6.2 we're getting into that area under the curve when we don't have a nice geometric shape, where we can't use geometry. So 6.1, the lesson ended with this example where we said we wanted to find the area under the curve between time equals 0 and time equals 2, but we had this curve. So the first way we're going to look at finding that area is we're going to use an approximation, and we're going to approximate the area using rectangles. So when using rectangles to approximate the area under curve, we must decide a few things in advance. How many rectangles will we use? Those are called subintervals. And just a little preview of coming attraction. Number of rectangles will be referred to as n most of the time. And then how do we determine the height of the rectangle? So left endpoint, midpoint, or right endpoint. So left endpoint is called a left Riemann sum, sometimes written as L ram. A right Riemann sum is a right endpoint, often written as R ram, and a midpoint Riemann sum, or using your height from the midpoint, is an M ram. Those will make more sense as we go through this. So this first one says use a left Riemann sum with one subinterval. So one subinterval means one rectangle. That's not going to give a great estimate. So remember, we're looking for the area under the curve from 0 to 2. So we're trying to estimate this whole area that I shaded in there. So this is saying use one rectangle with a left Riemann sum. So I'm going to use one rectangle. So this whole distance here is going to be the width of my rectangle. And I'm going to find the height of my rectangle from the left side of my curve. So this is my rectangle, sort of. You can think of my rectangle as that, but I'm not going to do the height of the rectangle here. I'm going to do it from the left end point of my curve. So my height's going to come from this point right here. That's where my curve has its end point when x equals 0. So this is going to be the rectangle that I'm using to estimate my area. So it's going to be 2, right? Because it's one tall and 2 wide. It's going to be 2. But you can think using this function, I'm plugging into this function to find my height. I'm plugging in t equals 0 because that is the left endpoint. So my area will be approximately, think of the height times the width. So my width of my rectangle is 2, and my height comes from this point right here. The way I get this height is I plug time equals 0 into my function. So I would have 0.5 times 0 squared plus 1. That would just equal 2 times 1. So my area would be 2, which we could see from looking at this. Now this next one is still using a left Riemann sum. So I'm going to get the height of my rectangle from my left endpoint. But now I'm doing 2 rectangles. So this is going to be one rectangle. So there's my width. In this case, W will be 1. Here's my second rectangle, and W will be 1 again. So my area is going to be, my width is going to be 1 for each of my rectangles. And I'm going to add the area of my first rectangle plus the area of my second rectangle. And again, I'm getting that height from the left endpoint. So you can think, oh, if I draw a rectangle here, the rectangle kind of looks like this, but I'm getting the height from the left endpoint. So I'm not actually using that. my height is going to come from my left endpoint. And then if you think about your next rectangle, which is right here, this is the left side of the rectangle. So when t equals 1, I want to go up until I hit my curve. And that's going to be the height of my second rectangle. So it's going to be this height, and this height, and both of my widths will be 1. So this height we know, it comes from plugging 0 into the function. So that's going to be the same as what we had above. And then again, this is my width, and this is my height. This is my width. This is my height. This is rectangle number 1, rectangle number 2. Rectangle number 2, the height comes from plugging t equals 1 into my function. So it's going to be 0.5 times 1 squared plus 1. So we already know from above that this is 1 times 1. So that gets us 1 plus, this is going to be half of 1. So that's 1/2 plus 1. So that's going to be 3/2. So 1 plus 3/2 equals 5/2 is my area here. Now you can see from looking at these two pictures that this is a much better estimate. All right, one more for this video, and then we'll probably do the rest of this lesson in class. So example 3 says use a right Riemann sum with 2 subintervals. So again, 2 rectangles. This is a RAM, and this tells you about where this name came from. These Riemann sums came from this dude, George Frederick Bernard Riemann. You can read about that if you want. So same idea as example 2, except this time I'm taking my height from the right side. So my first rectangle will be there. Here's my rectangle. The right side of my rectangle is at 1. The right side of my rectangle here is at 2. So you can see this is going to be an overestimate. This one that we had back here, as a matter of fact, both of these were an underestimate. For this function, the right endpoint, or the RAM, is going to be an overestimate. So my first height will come from plugging 1 into my function, and my second height will come from plugging 2 into my function. The width of both of these rectangles will be 1. So it's going to be 0.5 times 1 squared plus 1. So that's the height of rectangle number 1 plus width of rectangle number 1 times height will be 0.5 times 2 squared plus 1. So that's height of rectangle number 2. The first one we know from before is going to be 3/2. And the second one will be, this is 4, half of 4 is 2, 2 plus 1 is 3, so plus 3, so that's going to be 9/2. And this one you can see is an overestimate. So then what do you think would happen with our approximated area if we used more rectangles? So the more rectangles we use, we would obtain an area closer to the actual area. Remember, when we're using the rectangles, it's an estimate, but the more rectangles we use, the closer we would get to an actual estimate. Yeah, we'll do example 4 in class.